We will start our discussion with a general overview of testing. What is testing in general? Whenever we hear the term or the word testing, we often think about a QA team or maybe a testing team that is responsible for testing a software. They may be using some tools, it could be the manual testing, but we often think about a QA team. But that's not the case always. As a developer, we do the developer sanity, even if we know it or not knowingly or knowingly. So what do we mean by that? Think about it. Whenever we are making a code change, we do a code change. Then what we do, first of all, we compile that code and we check, okay, is this working fine? Is the compilation successful? If yes, we try to run the program, maybe on our local. So that is the step number 2. We compile and then we run the program. We see that, okay, the program is running. Then we do a sanity test. Maybe some simple tests to make sure that we did not break anything. The new code changes that we did, they did not break the existing functionality. So that is the sanity that we often do. It may be focused on a very small piece of functionality, or maybe an end-to-end functionality. It depends on the use case what we are developing. If we don't find anything, then yes, everything is fine, everything is good. But if we find a bug, we go to the same cycle again. We start with the code fix, that is, again we start making code changes, and then we repeat the loop. We compile, we run, we do the sanity test. So we do this all the time, knowingly or unknowingly. Now this kind of testing, it could be a manual testing. It means whenever we are making a change, we do all these steps manually. Or it could be an automated way of doing things. So maybe what if we have some way to write the test cases, some way to automate this cycle, so that whenever we are making a code change, we don't have to compile, run and do the sanity manually, but somehow the framework or maybe some tool can do it automatically. So that is testing in general. That is the agenda, or it is the foundation of the testing framework, and we will be discussing JUnit, that is specific to the Java applications. So when we talk about the testing in general, then by testing we mean we are trying to test the correctness of the program, the correctness of the software. It means whenever we develop a piece of code, it has some expectation that given the precondition, given the input, it should behave in a certain way. And that is the behavior of the program, the behavior of the software. And when we test that functionality, we test the correctness. Is the software working as per the expectation? That is point number 1. Next thing is, in the context of a testing framework like JUnit, we write code to test code. You got it? So the test case that we write is actually a code. In case of JUnit, it will be a Java code. So we write a Java code to test the Java code. So that is the funda of JUnits. We will see in the future videos how do we do that. But we need to remember that in case of the JUnit framework, we write code to test the code. Now the concept of JUnit is that it focuses on a single unit and it tests that single unit in isolation. When we talk about a Java program, because we will be talking about the JUnit framework, so in case of a Java program, the unit is mostly the class or a method. So we can write test cases, or we will write test cases that will cover or that will try to test the individual method. Is the method working fine? So that unit could be a method and it could be a class, but the thing is, the test case tests the unit in isolation, because you know that in a Java program we have many classes, then we create objects, we create dependencies, and one object may be using another object, one class may be using another class. But in JUnit we break that dependency, we break those relationships, and we test the unit in isolation. So if employee and address class, if they are related and we are writing a test case, then we will only focus on the employee class. We will try to isolate employee and address classes. So that's the concept of JUnit, and we will continue this discussion. We will see how to write code that will test the code, how do we set up JUnit, and what do we mean by isolation and a single unit. Okay, so that's it for now. That is only a very generic, a very high level overview of testing in general. See you in the next video. In this video, we will discuss why test cases are important. So we need to ask a question: how reliable a given software is. If there are no test cases, if we cannot test the correctness of the software, then there is no way to say that this software is reliable. We have no idea. We have no confidence as far as the reliability of that software is concerned. We don't know if this software will be able to handle the error scenarios in a graceful way. We don't know if it will work as expected. It will behave as per the expectations. So test cases make sure that we are able to test the correctness of the software so that we can say that a certain piece of code is reliable. So they are directly connected to the reliability of the software. Test cases are important. Second thing is, if we are making a change, then we want to know as soon as possible that did we break anything. So it's important to think about, if we are making a change, then how quickly can we test the change? And second point is related, how quickly or how quick our feedback loop is if we are making a new change. So if there are no test cases, then it may take some time to get the actual feedback depending on what we committed. But that's not desirable. We want to know as soon as possible. And if we have the test cases, then we can run the test suite and we can quickly know if we broke something. If there is any impact on the existing functionality, then we will have that information as soon as that test case completes its execution. So it makes sure that we can quickly test the changes, we can quickly test the correctness of the changes, and we can say that the system remains reliable over a period of time. All right. Next thing is, because there will always be better ways to do the same thing, maybe due to a language upgrade, maybe due to a certain dependency upgrade. But the thing is, maybe we found an efficient way to re-implement the same thing. But the thing is, if we don't have a test case to test that functionality, we cannot take the risk to change the code, to refactor the code. But if we have a test case to cover that functionality, then we can take the risk, we can refactor that piece of code, because we know if we made a mistake, then that test case will cover that mistake. It will fail, so we will know that, okay, we made a mistake. So if we have the test cases, then they make the refactoring a very easy task to do. Test cases make refactoring easy. And if we are refactoring the code base in a continuous manner, then the code base remains up to date and we can say that this code base is maintainable. All right, it's easy to maintain that piece of code. It's easy to make the new changes in that code base. It's easy to test the code base. So our code base, the system remains maintainable, and it is directly connected to the fourth point, that is the time to market. The thing is, if there is a new functionality that we need to release as part of the maybe release process, and if we are making new changes for that release, then in the absence of test cases, we cannot test them quickly as soon as possible. We cannot test them quickly. And because we cannot test them quickly, we cannot say that this system is ready to be shipped. That will delay the release. But if we have a strong suite of test cases, then we can test the changes quickly, we can complete the regression quickly, and we can deliver or we can release the software quickly. So in this video, we talked about why test cases are important. They make many important things much easier, such as refactoring, maintainability of the system, and the release process of the system. All right. We will finally start talking about JUnit. So what is JUnit? As per the documentation, JUnit is the testing framework for Java and the JVM. It is a testing framework for Java applications. By framework, we mean that we need to write certain piece of code because we need to write the test cases to test the Java code. But the JUnit framework will take care of many things. For example, initializing the context, clearing up the resources after each test invocation. All these things will be taken care of by the framework. We just need to write the test cases. The advantage of JUnit is that it is pretty simple to use. The new version of JUnit is heavily annotation driven. So using the defined annotations, we can quickly write a test case to test a Java code. It's much easier, much cleaner to write test cases using JUnit, especially for the Java programs. Another advantage of JUnit framework is we can easily run the test cases. We can run them manually using the IDE, for example, Eclipse or IntelliJ, or from the command line, for example, a Maven command, or we can integrate them with our CI/CD pipeline so that whenever we are checking some code, the CI/CD pipeline will start executing the test cases, and it will make sure that we collect the up-to-date information on the correctness of the code. All right, so we can not only write the test cases easily, we can run them easily, either manually or in an automated way. Then another major advantage of JUnit framework is that it detects the success and the failure statuses of the test cases. So if a test case is success, then yes, that data will be captured. If a test case fails, then JUnit framework has a graceful way to collect the result of the failure, to show them maybe the status as a report. It will not break the whole flow, but it will detect the status changes and it will collect the information accordingly. In the next video, we will see how to set up the JUnit and how to write the first JUnit test case. In this video, we will set up JUnit5 and we will write our first JUnit test case. To do that, we need to include the dependencies of the JUnit5, and to include the dependencies, we need to use a build or a dependency management tool. So there are options like Maven and Gradle, but I will be using Maven. You are free to use Gradle. And we need an IDE. So I will be using IntelliJ. Again, you are free to use IntelliJ or Eclipse, it doesn't matter. So I'm going to create a new project in IntelliJ. So I will create this new project. We'll give it a name, JUnit5 basics. And then I will choose Maven as my build system so that the dependencies will be managed and downloaded by the Maven. Then I'm using JDK 19. Again, you are free to use 8, 11, 17, whichever you are comfortable with. Okay, so let's create the new project. Because we created a Maven project, so by default we have this structure. It means under source we have two folders, main, which contains the business logic, and the test folder, which will hold the test cases that we will write. And then we have pom.xml, which basically defines the project architecture, project model. So all the dependencies will go in the pom.xml, and based on that, Maven will download the dependencies so that we can use them. All right. Before we set up the JUnit, let's first create a class that we will test. Okay, so we have the main class, the runner, but let's add a new class, greeter. And this greeter class will have a single method which returns a string. The method name is greet, and it will accept a string argument name, and it will return a greeting message, hi, and name. So if we try to run it, we will do something like this. We will create a greeter object, a new object of this class. Then we can call the greet method by passing any name, any string. So if we pass hello and if we run it, we see hi and hello, because hello is the string that we passed, and it will basically add the hi before the name whatever we passed. So we see the output hi and hello. So that is the a very basic class, and we will write a test case to test this class, to test the greet message. That is this single unit that we are going to test in isolation. Now we come to the JUnit5 part, the setup part. So here, if we expand the external libraries, we only see the JDK19, but we don't see anything related to the JUnit5. So we need to add those dependencies. To do that, we go to the JUnit5 documentation. Here it says example projects under the documentation, or we can go back to the home page. Here we go to the user guide, and in the user guide, there is this section example projects, and you can find many example projects based on the language and the build tool. So for example, Gradle in Java, Gradle in Kotlin, Gradle in Groovy. And because we are using Maven, so I will open this link, JUnit5 Jupyter Starter Maven. This is a project on the GitHub. All we need to do is we are going to copy the configurations from this POM, and we will paste the configuration in our POM. This one. Here, if we open the POM that was created by IntelliJ, so we see some values are already there: model version, group ID, artifact ID, version, Maven compiler source, and target source, which is basically JDK19. So what I can do, maybe I can simply copy the dependency management, dependencies, and build section. So let me copy and paste it here. Okay. Now we have the complete pom.xml, we have the properties section, then we define the dependencies. We are asking Maven to download the JUnit dependencies, this specific version 5.9.2, so that we can use it. This is basically the BOM that will handle all the dependencies, the compatible versions, and this is the dependency that we are going to download, JUnit Jupyter, that is required to run a JUnit5 test case. Then we have Maven plugins to do the compilation and to run the test cases from the command line basically. Okay, now I will simply refresh the POM from the IDE so that it starts downloading all the dependencies. Okay, so the status is now sync, and if I go back to the external libraries section, now we see additional Maven related dependencies jars in the external libraries section. So these all are JUnit related jars. Earlier there was only JDK19, but now we see the Maven downloaded all these JUnit related jars. So now we can write our first JUnit test case. Okay, so we know that as part of the convention, the test cases go to the test folder. Here we have the Java package, so we can create a new package, or we can simply write the test case under the Java package for now. So let me add a new test case. So we create a Java class, and by convention we use the name of the class that we are going to test, and then we append the test. So we say greeter test. Let's create the class. Now, how do we write a test case here? First of all, we create a new method public void, we give it a name. So let's say I say it test greet message, or we can say test greeter. So we give it a meaningful name so that it's easier for someone to understand what exactly are we testing in this method. Okay. Now, how do we tell JUnit framework that this is a test case, that it needs to run this test case as part of the build or CI/CD pipeline? So we know that JUnit5 is heavily uses annotations. So we use an annotation that says test. Notice we are importing it from the org.junit.jupyter.api. So we use this annotation @test to tell the JUnit that this method is a test case. So please run it as a test case. That's it. Now we will write the implementation to test the greet message of the greeter. To do that, we need the object of the greeter class. So we initialize a new object, same as we did in the main method. Okay. Then we need to test the greet message. So we see that it accepts a string argument, then it returns a value. There is an input and there is an output. To test the method, what we will do, we will pass it an input and we will get an output, and then we will test that output. So let's define an input. For example, we will pass it a string JUnit5. All right. Then we will call this method and we'll store the output in the output variable. So we say greeter.greet and pass this value. Okay. For now, let's just print the output and we will run it as a simple JUnit test case, same as we run the main methods. So we see that it is initializing the test and the test is success because we see this tick mark, although we are not testing anything. So by default it will be a success, but we see the output on the console high and JUnit5, and it is expected because if we pass input string, if we pass an input string, it will simply add the high. So we have all the setup. We declared it to be a test case. Then we have the class under test, basically the unit that we are going to test. We have the input, we call the output, and we want to test this method. So we have all the input and output. All we simply need to do is we need to tell the JUnit what is the expectation. How do you test this code? How do you test this execution? To do that, we use the assertion class. Now JUnit has many assert methods, and these methods test the conditions, test the expectations. We will explain all these things in the upcoming videos. For now, we are going to simply use it. So we use it assertions.assert equals because we are going to test the equals condition. We are going to check if the output is same as the expected value. So we are checking the equals condition, and due to that, we are going to use assert equals. Now, if we go to the assert equals, it has two parameters. The first one is the expected and the second one is the actual. Okay, so in our case, the actual is going to be output, that is the actual output that we get from the method execution when we are passing an input. So that is going to be the actual value. For expected, we know that if we pass a value, then we expect a value in this format, means high JUnit5, because we know that we are passing this value as input. So in the output, we should see this message. So this is the expectation. Now this method will tell JUnit framework that this is the expected value and this is the actual value that is coming from the method execution. So you need to test if these two values are equal or not. If equal, then this test case is a successful test. If not, then you should report an error. So let's run it. And here we see that this test case is green. It is success. And because we are not printing anything on the console anymore, so we don't see anything on the console. But the important thing is that we wrote our first JUnit test case which is green. There is no error. So this test case is green. And just to recap, what we did, we created a new test class in the test folder. Then we created a method. We tagged it with the @test annotation so that the JUnit framework knows that it is a test. Then we created the new object of the class that we want to test. We have the input. We call the method that we want to test, which is greet. We pass the input. We got the output. And based on that, we have the expected value. We have the actual value. And we passed these values to JUnit framework using assert equals, and we told JUnit that these two values, you need to assert that these two values are same, expected and the actual. And in this case, because it is same, so this test case is green, there is no error. Now, the advantage of JUnit is, for example, after 2 months, someone is making a code change in this greet method and by mistake, the I got removed. Now, if we don't have a test case, this probably will be missed. But if we have the test case and when this code is checked in, it will probably be triggered as part of the CI/CD pipeline. And when JUnit will run this test case this time, it checks, it will see that the actual is not same as the expected. So this is an error, and this time we got a test failure that expected was high JUnit5, but the actual is at JUnit5. So input and output, they are not matching anymore. And now we have the failure test case. So that is the advantage of JUnit. We can quickly make the code changes and we can quickly fix them. All right.